Before trees as they are known today ever cast shadows across the land, there was a quieter beginning, one that reshaped the surface of the planet in ways that are still felt. The first forests did not arrive suddenly. They emerged slowly, almost invisibly at first, from a world that was once bare, silent, and exposed. More than 400 million years ago, during the Devonian period, the continents were largely lifeless expanses of rock and sand. There were no deep soils, no complex ecosystems, and no towering vegetation. The land was shaped by wind and water alone. But along the edges of rivers and damp lowlands, something began to take hold. Early plants, simple in form and limited in height, started to spread across These first land plants were small, lacking true roots, leaves, or wood. They resembled thin, branching stems that absorbed water directly from their surroundings. Yet even in their simplicity they carried the beginnings of a transformation. Scientists believe these early pioneers gradually altered the chemistry of the soil and atmosphere, breaking down rock and contributing to the formation of the first stable surfaces capable of supporting more complex life. Over millions of years, a critical evolutionary step changed everything. Plants developed vascular systems, internal structures capable of transporting water and nutrients. This innovation allowed them to grow taller, to rise above the ground, and to compete for sunlight. It marked the true beginning of vertical life on land. Among the earliest of these vascular plants was Cooksonia, a small but significant species that represents one of the first known attempts at structured growth. It had simple branching stems and spore-producing tips, but no leaves. It was not a tree, and yet it carried the blueprint that would eventually lead to forests. As time progressed, plants became more complex. They developed stronger support structures, primitive roots that anchored them into and increasingly elaborate branching systems. By the middle of the Devonian period, the first tree-like plants had begun to appear. One of the most important of these was Archaeopteris. It is often described as one of the earliest true trees, though it was unlike anything growing today. It possessed a woody trunk capable of supporting significant height, and a system of branching limbs covered in fern-like leaves. These leaves allowed it to capture sunlight efficiently, while its root system stabilized the soil around it. For the first time in Earth's history, landscapes began to change in a dramatic way. Instead of flat expanses, there were now vertical structures rising into the air. Clusters of these early trees formed what can be considered the first forests. They were not as dense or diverse as modern forests, but they marked a fundamental shift in how life interacted with the environment. These early forests began to influence the planet on a global scale. Their roots broke apart rock, accelerating soil formation. Their leaves absorbed carbon dioxide and released oxygen, gradually altering the composition of the atmosphere. Scientists believe that this period of forest expansion played a role in reducing atmospheric carbon levels, which may have contributed to global cooling. The presence of forests also affected water cycles. Their roots helped retain moisture in the soil, reducing erosion and stabilizing river systems. Rainfall patterns may have shifted as vegetation influenced the movement of water through the environment. In many ways, these early forests began to regulate the planet itself. But this was only the beginning. As the Devonian gave way to the Carboniferous period, the world entered a new phase of ecological expansion. The climate in many regions became warm and humid, creating vast swampy environments ideal for plant growth. In these wetlands, forests reached a scale and density that had never existed before. Towering lycophytes such as lepidodendron dominated these landscapes. They were not trees in the modern sense, but they grew to immense sizes, with tall, straight trunks and a crown of leaves at the top. Their bark bore distinctive patterns, marking where leaves had once been attached. Alongside them grew Sigillaria, another giant with vertical ridges running along its trunk. These forests were dense, humid, and filled with life. Giant horsetails, known as calamites, formed thick stands along the water's edge. Ferns spread across the forest floor, their fronds unfurling in the moist air. Seed ferns added another layer of complexity, bridging the gap between spore-based plants and those that would later dominate. The air itself was different. Oxygen levels were significantly higher than today, partly due to the immense productivity of these forests. The environment was rich, stable, and perfectly suited for the continued expansion of plant life. And yet, even at the height of their dominance, the seeds of change were already present. The success of these forests depended heavily on moisture. Many of the dominant plants reproduced through spores, which required water to complete their life cycle. As long as the environment remained wet and stable, this system worked efficiently. But the Earth was not a static system. Gradually the climate began to shift. Toward the end of the Carboniferous period, tectonic movements and changing atmospheric conditions led to drier climates in many regions. The vast wetlands that had supported these forests began to shrink. Seasonal variations increased, and areas that were once consistently humid experienced periods of dryness. For spore-producing plants, this change was devastating. Without reliable moisture, their reproductive cycles became less effective. Populations began to decline, and forests that had once stretched endlessly across the land started to fragment. At the same time, a new group of plants was gaining an advantage. Seed plants had evolved a revolutionary adaptation. Their seeds protected the developing embryo, stored nutrients, and could survive in dry conditions for extended periods. This allowed them to colonize environments that were no longer suitable for spore-based plants. As the climate continued to change, seed plants spread rapidly. They occupied new niches, outcompeting older plant groups that could not adapt as quickly. The balance of ecosystems began to shift. The decline of the first forests was not sudden. It unfolded over millions of years, a gradual process of retreat and replacement. In some regions, remnants of these ancient ecosystems persisted, holding on in pockets where conditions remained favorable. But the overall trend was clear. The age of the first forest was coming to an end. Then, around 252 million years ago, Earth experienced one of the most catastrophic events in its history, the Permian mass extinction. Massive volcanic eruptions released enormous quantities of gases into the atmosphere, leading to extreme climate change. Temperatures rose, ecosystems collapsed, and life on a global scale was pushed to the brink. For the already declining forests, this event marked a final collapse. The environmental conditions that had once allowed them to thrive disappeared. Many species were unable to adapt to the rapid changes. Entire lineages vanished, leaving behind no direct descendants. What had once been the dominant form of life on land was reduced to fragments preserved in the fossil record. What followed was a world transformed. New plant groups emerged, adapted to the changing conditions. Seed plants diversified, eventually giving rise to the gymnosperms and later the flowering plants that dominate today's ecosystems. Forests returned, but they were different, composed of new forms shaped by new evolutionary pressures. The first forests did not simply disappear without consequence. Their impact remains deeply embedded in the planet. The coal formed from their remains continues to exist beneath it, a record of their immense scale and productivity. The changes they made to the atmosphere helped pave the way for complex life. The soils they helped create continue to support ecosystems today. Even their extinction played a role in shaping the future. By making way for new plant groups, they opened the path for the diversity of life that would follow. There is something profound in this cycle. The first forests rose from a barren world, transformed it, and then faded as conditions changed. Their story is not one of failure, but of transition. They represent a moment in Earth's history when life expanded in new directions, experimented with new forms, and reshaped the environment in lasting ways. Today, forests once again cover large portions of the planet. They seem permanent, enduring, and familiar. But the story of the first forests is a reminder that even the most dominant ecosystems are temporary. Beneath layers of rock and sediment, their remains still lie hidden, silent evidence of a world that once stood tall, breathed deeply, and then slowly disappeared. The rise and fall of Earth's first forests is not just a story of the past. It is a reflection of the ever-changing nature of life on this planet, where even the greatest empires of green are, in time, replaced.